Kia ora class. Today we're going to be talking about another biomechanical principle. This one is called force summation. The learning intention for today is that we're going to be describing the concept of force summation and applying this principle to the performance of physical activity. So, first of all, what is force summation? Well, to give an object acceleration, that is, to make it shoot off in any given direction, the amount of force given to that object is determined by the sum of all the forces generated by each part of your body. Okay? And that definition comes from the NCAA Level 1 Physical Education Study Guide. Basically what this is saying is that force summation is about generating the biggest force possible with the movement that the human body has to offer. How can we maximize the force that the human body is generating? This is often useful in sports where you're trying to jump higher or hit harder or throw further than someone else. So, how can we generate maximum force? There are 4 things that we can do to help us achieve that maximum force possible. The first thing is we can use as many body parts as possible. The more muscles used, the greater the summation or the total force that you can transfer to an object. Obviously, if you're trying to throw something and you just use your arm, you're going to be able to generate less force than if you use your legs and your torso and your shoulder to contribute force to that movement as well. The total force you can generate will be greater with more body parts. Alright, this here is a super slow motion video of a clean and jerk weightlifting skill. You can see at the start the athlete's mostly using his legs and back, but here a lot more body parts are recruited. We can see biceps, we can see shoulders, we can see the gastrocnemius, his calves pushing down, and we could see his trapezius and the top of his neck all working to contribute to the overall force created to lift that massive weight. If he didn't use all of those body parts, he probably wouldn't be as successful in that skill. So, step number 2. Now that we've decided we need to use all these different body parts to create the biggest total force at the end, we actually need to get them in the right order to ensure that we achieve that. If we get the sequence wrong, then we won't achieve maximum force. So, body parts need to move in this correct sequence. If you try and move all the body parts together at once, you're going to get it wrong and you're not going to achieve maximum force. The biggest muscles in your body are the ones that need to go first. They need to start off the movement, and then you go through the sequence smaller, smaller, smaller until you hit the smallest muscle being used, and that will be the one that goes last. Right, so I have a little demonstration of how the correct sequencing may be applied in a basketball jump shot. Okay, the muscles being used, there's quite a few, but this is the sequence that they should go in. Remember, we're going from biggest down to smallest. We'd start with the quadriceps, big muscles in your legs, followed by the gluteals, also quite big. Move on to the pectorals on the front of the chest, again quite big. Now we're getting a little bit smaller down to the deltoid in the shoulder, the tricep in the upper arm, and then lastly, the smallest muscles involved in this are the wrist flexors, the muscles that move the wrist. Okay, we can see this in this diagram here. You can see the first things to fire are this athlete's legs. Yeah, we can see some orange arrows indicating that force is being generated by the legs, by the butt, at the knees and the hips. The next thing to fire is the shoulders and the upper arms, bringing those arms up. That is the next thing to fire. We're transferring that force from the legs now to the arms, and finally out to the wrists, to the hand, and into the object that we're trying to send flying. Step number 3. Correct timing. Muscles need to be used and accelerated with the correct timing. We've got all the muscles involved, we've got them going in the right order, but again, if you get the timing wrong, you're not going to hit that maximum force potential. When trying to produce maximum force, each segment should be moved the instant the previous segment begins to slow down. This is to ensure that no force is lost between the body parts and that the last body part is the one that's moving the fastest with the most force to transfer that force onto the object. Alright, I have here a graph that I'm going to use to try to help demonstrate
the importance of correct timing as part of force summation. I've started by identifying the muscles involved in a jump shot, and I've ordered them, I've put them in the sequence from their biggest muscles through to the smallest muscles, and you can see that based on the size of the symbol there. Now, each symbol represents a single muscle or muscle group firing. You can see here, this one is the quadriceps. At this point here, this is where the brain sends a signal that that muscle needs to start doing work. It needs to start producing force. That force increases quite quickly over time to a point somewhere near the top, and we would say that's where the maximum force of that muscle is being generated. After that point, the force that it's generating, the speed it's working at, starts to diminish back to nothing. Now, the principle of correct timing says that we need to be firing the next muscle right at that top point there where that maximum force is being generated. So to illustrate correct timing, we'd start with the quadriceps. The next muscle would be the gluteals, and that muscle is going to fire right at the point where the quads hit their maximum force. Any time after that, and you're going to lose force. You're going to not be able to achieve that maximum force. The next one to go will be the pectorals, followed by the deltoid, followed by the triceps, and lastly, the little wrist flexors. And we can see that we have generated quite a good amount of force here, right off my graph here, by getting the timing correct. Now, if I got the timing incorrect, say my glutes fire a little bit late, they fire after the point where things are maximized. Everything else stays the same. Cool, so everything else fires in the correct timing, but the glutes just fire a little bit late after the quads. You can see that the overall force that I was able to achieve here is less because the timing was incorrect.
Step number 4 is we need to use the greatest range of motion possible with all our muscles. Each muscle should go through its greatest range of motion so it can accelerate to its maximum speed and therefore generate the maximum force. If you only move your muscles a little bit, they're probably not going to generate the maximum force that they can to contribute to your overall movement. If we have a look here, we have two golfers. Imagine these golfers have swung back their golf clubs and they're about to start swinging forward with their club. Which golfer do you think is going to be able to hit the ball the hardest? Why is that? Lastly, why is maximum force important? The success of many physical activities is determined by the amount of force that an athlete can generate. That is, the person who is most likely to win is usually the person who can transfer the most force to the object that they are playing with, or to their own body when executing skills, or to the opposition body when they're trying to tackle them, for example. So what you're going to do now is you're going to have a think about what activities you know of that rely on athletes being able to generate maximum force in order to be successful or better than their opposition. That's us, team. That has been our explanation of force summation and how we apply it to the performance of physical activity.